Approximately 24,000 years ago, a small group of modern humans set up camp above the Arctic Circle in what is now northern Siberia. The temperature outside was -40 degrees. The nearest trees were 500 kilometers south. There was no natural shelter within walking distance. They stayed for generations. Researchers are still trying to understand how. The Last Glacial Maximum, the period between roughly 26,000 and 19,000 years ago, was the coldest sustained interval our species has ever lived through. Ice sheets, 2 miles thick, buried everything north of modern London. Sea levels dropped 120 meters. The woolly mammoth is gone. The cave lion is gone. The woolly rhinoceros is gone. You are not. This is not a story about endurance. It is a story about a species that looked at an extinction-level climate event and refused to lose. Number 5. The needle and the shelter. When the glaciers pushed the tree line 500 kilometers south and wood disappeared from entire landscapes, our ancestors replaced it. At Prehistoric, in central Ukraine, excavated and analyzed by Olga Sofer at the University of Illinois, archaeologists uncovered 4 structures built almost entirely from mammoth bone. The largest used 149 individual mammoth bones assembled into interlocking walls. Skulls formed the base layer. Long bones were stacked vertically. Jaw bones were arranged in herringbone patterns that distributed structural load. The roofs were stretched hides, supported by ivory poles. Radiocarbon dating placed the Mesozoic structures at approximately 15,000 years ago. These were not improvised shelters. The construction required planning, specialized knowledge of load distribution, and a coordinated labor force capable of moving bones that individually weighed hundreds of kilograms. But shelter alone was not enough. What filled it mattered as much as the walls themselves. The oldest bone needles in the archaeological record date to approximately 50,000 years ago from sites in Siberia. These are not crude instruments. They are small, precisely manufactured tools with eyes drilled through the narrow end, capable of pulling sinew thread through multiple layers of hide with enough precision to create fitted seams. Modern Arctic survival research, published through the Defense Research and Development Canada program, confirms that a well-fitted, layered garment reduces metabolic heat loss by a factor of 4 to 6 compared to loosely wrapped coverings of equivalent material. Our ancestors understood this principle empirically 50,000 years before anyone wrote it down. They arrived at the worst cold the Pleistocene produced, already carrying the technology to survive it. The bone walls kept the wind out, the needle kept the heat in. Number 4. Fat as strategy. The human body stores energy as fat in a pattern that is physiologically unique among the great apes. Humans carry approximately 15 to 25% of body weight as fat. A healthy adult chimpanzee carries roughly 3%. This disparity was studied by William Lassick at the University of Pittsburgh and Stephen Gollin at the University of California, Santa Barbara, whose 2008 work examined the evolutionary function of human fat storage in comparative perspective. The argument that emerges is that human fat storage evolved as a buffer against the feast and famine cycles of a mobile hunter-gatherer existence in cold environments. The archaeological evidence confirms the priority. At Ice Age sites across Eurasia, the butchery patterns visible on animal bones reveal a systematic and deliberate focus on fat extraction that goes beyond caloric opportunism. At Pavlov in the Czech Republic, dated to approximately 26,000 years ago, faunal assemblages studied by Jiří Svoboda of the Czech Academy of Sciences show the systematic processing of every available fat source, including brain tissue, periosteum fat, and bone grease rendered through boiling. Fat delivers 9 calories per gram, compared to 4 calories per gram for protein. In a cold environment, where the body burns enormous quantities of energy, maintaining core temperature, fat is not a dietary preference, it is a survival priority. The hunters were not simply feeding themselves, they were fueling a metabolic system designed specifically for cold weather endurance, and they understood at a practical level exactly which animals would keep them alive through a Siberian winter. The mammoth steppe was a freezer. Our ancestors had figured out how to run on it. Number 3. The social network. In 2020, a study led by Mark Thomas at University College London and published in Science Advances analyzed the social structure implied by long-distance raw material transport at Upper Paleolithic sites across Eurasia. Baltic amber appeared at inland sites in Central Europe. Mediterranean shells appeared at sites in the Pyrenees. Specific flint types were moved across distances, implying trade networks or seasonal migration routes, spanning entire ecological zones. Thomas and colleagues argued these patterns reflect a level of social connectivity between geographically dispersed human groups that had no equivalent in any earlier archaeological period. The survival implication was profound. A group of 25 to 50 people, The typical size of a mobile hunter-gatherer band is genetically and demographically fragile. A single bad winter, a single epidemic, a single failed hunt can eliminate enough members to make the group non-viable. The solution was connectivity. A group embedded in a network of allied groups spread across a landscape large enough to include multiple microenvironments meant that a local catastrophe did not mean extinction. It meant temporary displacement and assistance from allies currently experiencing better conditions. The shells and amber and exotic stone moving between Ice Age groups were not luxury goods. They were the physical tokens of a social insurance system. The humans who made it through the last glacial maximum were not the toughest individuals. They were the most connected ones. Number 2. The population bottleneck. Approximately 70,000 years ago, possibly connected to the eruption of the Toba supervolcano in Sumatra and the volcanic winter that followed, the global human population crashed to an estimated 10,000 to 30,000 breeding individuals. This figure, derived from genetic diversity analysis in modern human populations by Stanley Ambrose at the University of Illinois and published in the Journal of Human Evolution in 1998, represents a population so small that a single epidemic could have ended the human lineage entirely. The species came within a measurable distance of extinction. It did not go extinct. The people who survived were not physically different from those who did not. They were behaviorally different. Sally McBrearty at the University of Connecticut and Allison Brooks at George Washington University documented in their landmark 2000 paper in the Journal of Human Evolution that the period following Toba saw a marked intensification of symbolic behavior, long-distance trade, technological innovation, and social complexity across Africa. What the bottleneck appears to have done is filter the human population for the specific traits that made survival possible. The groups that made it through were the ones with the most developed social networks, the most sophisticated technological traditions, and the most effective mechanisms for transmitting knowledge across generations. The Ice Age that followed inherited a species that had already been tested by near extinction. It had already begun building every tool it would need. Number 1. Why they made it. Every other species that faced the last glacial maximum faced it with the tools evolution had given it. The woolly mammoth had its insulating coat. The cave lion had its cooperative hunting. The cave bear had its capacity for hibernation. These were fixed solutions to fixed problems. They worked until the problems changed. Then they stopped working entirely. Our ancestors had no fixed solutions. Every generation refined what the previous one had built. Better needles, better shelter construction, better understood migration corridors, better encoded knowledge of which valleys held game when the open steppe became uninhabitable. The knowledge compounded. It did not reset. A human group in 20,000 BCE was not doing what a human group in 30,000 BCE had done. It was doing something more refined, built on 1,000 years of accumulated failure and correction that the previous generation had already paid for in full. The megafauna of every continent had survived multiple previous glacial cycles. They had adapted to dramatic climate shifts across millions of years. What they had never encountered was a species whose adaptations improved faster than any prey animal could evolve a defense. The mammoth steppe is gone. The animals that crossed it are gone. The thin, cold, perpetually innovating bands of humans who walked it are the reason you exist in a temperature-controlled room having consumed a meal that required the coordinated labor of hundreds of people to produce. The Ice Age did not end because the glaciers retreated. It ended because the species that survived it was already building a world that made glaciers irrelevant. Everything your ancestors endured in those bone shelters, in those frozen valleys, in those lamplight hours of sowing and teaching the next generation what it needed to know, ended here, in you.